Hey, how you doing today? All right, so I'm back. After I showed you in the last problem, we did a conditional proof inside a conditional proof. Now I'm going to show you a little bit more complex problem where we're going to do a conditional proof inside of an indirect proof. So let's look at our problem up here. My conclusion says not Z. So one of the best strategies I can use right here is called indirect proof. You are already familiar with indirect proof, but in this particular case, what I'm going to show you is a conditional proof inside of an indirect proof. So as is typical, what we're going to do is we're going to assume Z via indirect proof. Okay? Now that I've assumed a Z, what I can do is I can plug it into 1 and use my rule modus ponens to derive the consequent of premise 1. And again, that's from line 1, line 3, rule modus ponens. Now that I've done that, notice that my premise in line 4 is a conditional. My main operator's here, but I also have a conditional as my antecedent. So what I'm going to do here is I'm going to do another proof. I'm going to move in and do a conditional proof here. So at line 5, what I'll do is I'll assume B via conditional proof. Now what I can do is I can take line 5 and by rule of addition, I can add a B to it. Now if we look at our rules of replacement, we'll notice that the tautology rule comes in handy here. If I have B or B, then that means I have B. So by rule of tautology, I can derive my B here. Now remember, I assumed a B is a conditional proof. I've derived a B on line 7. So I can close this out, bounce back out, and now I've derived if I have a B, then I have a B. And this will be from 5-7 conditional proof. Okay. Now if you'll notice, number 4, my antecedent just is B implies B, which is exactly what I've derived on line 8. So through the rule of modus ponens, I can plug it into line 4 and cash out a G. Which is exactly what I was trying to do, because if you notice, your second premise, the antecedent is a G. Now that I've derived a G, I can use modus ponens once again to derive the consequent of premise 2. So that's exactly what we'll do. So 2, 9 modus ponens allows me to cash out this entire consequent. Now something I failed to mention earlier that I want to talk about right now is, remember, we open with an indirect proof. And when we do an indirect proof, our goal is to derive a contradiction. If we derive a contradiction, then we show that whatever we assumed in our indirect proof, which in this case was Z, is not the case. Now remember, our conclusion is not Z. So if our conclusion is not Z, and we assume a Z via indirect proof, cash out a contradiction, then we know not Z is the case, which is exactly what we're trying to get to. When we first started working on this, I noticed that I have a K and not K right here. So if I can get to that K and not K, then I'll have derived my contradiction. Hence the reason that I worked to get this G so that I could then get the consequent of this conditional. Now the goal is to try to get to this K and not K. So what I'm going to do here is I'm going to use one of our handy rules of replacement, exportation. Now, exportation tells me that if I have if H, then E implies H, that I have H and E implies H. So we can do that. And we'll leave this one alone. Remember, on your rules of replacement, you can do them on parts of lines. And that's exactly what I did. I took the antecedent of this conditional, and I applied the rule of exportation to it to get H and E implies H. Okay? Now that I've done this, I'm going to do another conditional proof. So we can move it in. And I'll assume H and E via ACP. Okay? And now we all know what I can do with this. If I have a conjunction, I can simplify the left-sided term. So I have H and E. I will simplify now to have H. That's from line 12, simplification. All right. Now that I've done that, notice what my antecedent is to this conditional. It's H and E implies H. Okay? I have assumed H and E as a conditional proof in 12, and then derived an H via simplification. So when I cash this out, I'm going to get H and E implies H, which is exactly what I was looking for. So we pull it back out, and we'll get H and E implies H, and that will be from lines 12 through 13 conditional proof. Hopefully at this point you see exactly what we're going to do. Because my very next move, I'm going to take this antecedent, I'm going to plug it into line 11, right? Rule modus ponens again, and I'm going to derive my K and not K, which was my goal to begin with. That way I have a contradiction, and I'll know that my Z is not the case, which is what we're trying to get. So let's do that. So at 15, I get K and not K, and I get that from 11 and 14 modus ponens. Now I've derived a contradiction. And remember, we started with an indirect proof. I assumed a Z. I've now derived a contradiction. So what I've shown is that Z cannot be the case. If when I assume a Z, I get a contradiction, then it must be the case, not Z. So we can close out this entire indirect proof. We bounce back out here. It's 16. And we claim not Z. And we claim that via 3 through 15 indirect proof. 3 through 15 IP. Not Z was my goal. Not Z is what I've derived. The problem is solved. I hope this helps you out. I know it's a little bit more complex than the ones you've been dealing with, but notice that sometimes it's real handy to do a conditional proof inside an indirect proof, particularly when you have premises that are conditionals themselves. All right? Everybody have a good day.